Hello everyone, we are dybp. Today we are going to share our concept report with everyone. Here we have the list of our team member. Team leader 世勋廖 and team member 洪光劝 and 年瑶周. Firstly, let's discuss the algorithm. Given that the core functionality primarily involves comparator, we aim to make the core function of the main module similar in order to minimize the area usage. Function 1 and 2 involving finding the maximum and minimum value among each set of A number. As illustrated, when executing function 1, we sequentially compare each incoming input value. If it meets the condition, we store the value. Otherwise, we delete it. Functions 6 and 7 perform the same operation on 96 data according to the methodology of function 1 and 2. Regarding function 3, calculating average, we have a different approach. To avoiding usage a division operator, as it would significantly increase the area due to bit count. We decide to increase the bit count for storage, adding up the value and consider the first 122 bits will yield the average of 8 items. Function 4 requires output value to satisfy two specific conditions. Whenever function 5 necessitates output value to fulfill only one of the specific conditions. Page 3, we are going to discuss the circuit architecture of current design. Detail the functionality corresponding to the component. We will categorize them into three main types. The first type, including function 1, 2, 6, and 7, employs a shift to handle 122-bit value as input. Additionally, a counter is used to detect the completion of inputs. Compares two value and storage the large number for the subsequently comparison. For functions 6 and 7, seeking exchange value among all data, the circuit can efficiently reuse the aforementioned logic by comparison all data from start to end. Regarding the functionality in third type, we specifically allocated 131 bits. This design is for storage purpose. It can replace the division operator to extract the average value. However, it requires additional adder unit to sum all value already divided by 8. Function 4 and 5 require an extra register as we need to simultaneously store the maximum, minimum, and pending value. In our course, we will cover many known topics such as application of basic component, structural design, and synthesis technique used after design completion. However, there are areas we still need to learn, particularly sequential circuit design. Although we practiced using sequential circuit in the previous traffic light problem, the modules used this time are more complex. Therefore, we anticipate the need for a deeper understanding of sequential circuit design. Additionally, our course involves comparison algorithm. To generate more noticeable advantage, we will explore whatever there are better algorithm or data storage method available that can significantly optimize our circuit. Coding coverage is an important metric in software development used to assess the extent to which test cases cover the code base by calculating the proportion of coding that has been tested. It helps developers understand the comprehensiveness of testing, identify areas of coding they lack testing, and provide direction for improvement. Now we are going to introduce our to-do list and member assignment. First of all of us were part of the design process together. Instead of just improving the algorithm, this time we really focus on using module over and over again, which save a lot of space overall. Right now, we are thinking about combining function 1, 2, 6, and 7, and also merging function 3 and 4. Following that, our strategy include putting the entire module into action. Each team member has the job of creating their own module at the start. Later on, this module will be assessed and combined using a scoring system. Even though this start phase might take longer, it guarantees that everyone understands the code and goal clearly. This, in turn, boosts efficiency when we later put everything together and fix any issue. The following steps include quietly combining the confirming the module. Following the saying, first aim to have something, they aim to make it better. The main goal is to create a first draft that works functionally. Another important stage involving optimizing the circuit for crucial upcoming phase. Ideally, we are looking to gather more literature that could help us tweak our algorithm or further strengthen our module. Afterward, our attention turned to comparative documentation task, where we will translate our design accomplishment into a written report and presentation. This covers our upcoming task checklist. Number 6. This is our schedule. We are finished the conceptualization phase and are now working on the initial coding. Our aim is to complete the initial coding by next week. After that, we will allocate 2 to 3 days for synthesizing and testing module while simultaneously beginning work on the progress report. Once we confirm the modules are working correctly, we will start the optimization phase. This optimization process will run until the complete of progressing report, incorporating the best practice for other teams. Finally, we will begin refining the final project report. This schedule outlines our timeline. Number 7. Possible issue and expect solution. Here are anticipating problem and the method we expect to use to resolve them, categorized into 3 main aspects. Firstly, there is concern about potentially difficulty in implementing algorithms successfully. Since algorithms are conceptual, they might face significant issues during execution that can be easily fixed. In such case, we might temporarily switch to a simpler but less efficient algorithm to make progress. Secondly, there is the issue of excessive space usage. With the need of 7 functionality in the design, it's likely that without specific optimization, the space required will be substantial. To tackle this, if needed, we plan to use gate-level implementation and continuously combine modules with similar functions to reduce component usage. Lastly, the challenge involves synthesis failure. a problem that has been encountered in recent assignment. To handle this, our first step would be to check for the potential creation of latches and investigate any instances of time violation. It's also crucial to review and confirm that our coding style is adequate and compatible with synthesis requirements. Finally, thank you all for listening. This concludes our dybp concept report. We hope everyone successfully complete their end of term project.